Hello learners, welcome to Constant Learners. In today's video, we are going to discuss relational algebra. So first we'll start with the introduction. What is relational algebra? Why do we need relational algebra? What are the characteristics? And what are the operations in relational algebra? Let's start. Relational algebra is used for relational databases. We've already discussed relational databases ample amount of times. What are relational databases? The databases where the data is stored in the form of tables or relations. Correct? Now, we store the data inside the database so that we can access it in the future. We need to use this data. It's not being stored for the purpose of just storing it, for keeping it, right? We're going to use it for the benefit of the society, for the benefit of the businesses. Now, to access this data, we need some kind of communication medium to communicate with the databases. And relational algebra is a query language. So relational algebra is a query language that we can use to communicate with the databases. Correct? But this is not the end of it. There's a lot that we need to understand because relational algebra is not directly used. It is just a medium. We're going to look at it in a bit. Now let's start with the basics of relational algebra and why do we need it. In the previous video, we've already discussed that relational algebra is a procedural or formal query language, right? We've done this in previous video. You can watch that video. I will link it in the description as well as above. So what is a procedural query language? Whenever we are communicating with the database or whenever we query the database, we need to mention what we need. That is, what exactly are we trying to do with the database? Whether we are trying to save some data, whether we are updating the data or fetching some kind of data from the database, right? So we need to inform the database what are we wanting or expecting in the form of the result. Correct? But in procedural query language, along with what, we also need to mention how. That is, what data we need, along with how exactly are we expecting the database should fetch the data from the database. Right? If you don't understand this, kindly refer to the previous video. So relational algebra is a procedural or formal query language that we use to communicate with relational databases. Now, let's head to the next point, which is relational algebra is a set of operations that we perform on relations. So we are performing some kinds of operations on relations, that is tables where the data is stored. But what set of operations or what kind of operations? Just like mathematics, right? In mathematics, we input two numbers. We give what do we need two numbers to do, whether we need to add, subtract, multiply, divide. These are the set of operations and there are many more. So we input the numbers, we tell it what we need to do and we get the output. Similarly, in relational algebra, we give the input, that is what we need, along with how we need, and it performs some set of operations and then fetches the data from the database, right? So it takes the input, performs some operations and provides us with an output, right? Some operations are being performed to fetch the output. And what is the input? Along with what we need, how we need, that is our input. Some operations, some mathematical operations are performed and finally we receive the output. I hope this much is clear. Next, relational algebra is a fundamental concept in database, which is serving as a theoretical foundation for relational databases. Now, what do we understand with this? That it has not been directly implemented on any databases. It is just a concept which is serving as a theoretical foundation. However, it has heavily influenced the design and implementation of database systems and query optimization techniques. What is query optimization? We'll get to it in just a bit. But in short, the relational algebra is just a collection of many mathematical expressions that provides us the base for database query languages to communicate with the databases. So database query language is different, like structured query language, right? But this structured query language is based on what? It is based on relational algebra. So relational algebra forms as the base for the database query languages so that we can communicate with the databases. But why relational algebra? Why are we only using relational algebra as the base for database languages? Because relational algebra provides us a set of operations that can help us to get better understanding of database operations. That means whatever query we are giving the database, whatever operations that we want the database to perform, that can be better understood with the help of relational algebra. That can be better solved with the help of the set of operations present in relational algebra, right? And it helps us to create more optimized queries. Now, what are optimized queries? Optimized queries are those that are short and fast and reduce the load on the databases. So these queries have to be quick. These quick queries have to be fast so that the databases are not getting overloaded or worked out, or they should not slow down. There are many different ways of solving a mathematical problem. Similarly, in here, in relational algebra, there are many different ways to finding the data from the database or to solve the query that we are giving to the database. So, many different kinds of queries can fetch the same data that is required. But optimized queries will help us to do it faster without putting extra pressure on the databases. All right. I hope you've understood why do we need relational algebra and what are optimized queries. There are multiple ways, there are multiple queries to fetch a data from the database or to perform any operation on a database, but we need to use the query that is faster and more efficient. Now, since we've understood the basics of relational query language, let's quickly discuss the characteristics. The first one will be it is a set of mathematical operations that can perform any kind of operation on the database. We've already discussed that. There are many mathematical operations. We will discuss these mathematical operations in the future. And thus, relational algebra is capable of performing any kinds of tasks or any kinds of operations on the database. Next is multiple queries can fetch the same data or perform the same operations. This we've just discussed. But we need to select the one that is more optimized. That means that is more fast. That is preventing the load on the database. And that is possible with the help of relational algebra. So data optimization aims at improving the query performance. How are we improving the query performance? By reordering the operations. So it is possible in relational algebra to reorder the operations. Just like in mathematics, we have the BODMAS rules, right? So similarly, the relational algebra has its own way of reordering the operation. That is, which operation should be performed first so that the query can be resolved faster. So that is one way of improving the query performance. Another would be by applying algebraic equivalences. That is, equivalent operations we can use. Third one is utilizing indexes and other optimization strategies. And there are many more other optimization strategies available with relational algebra that can help with improving the query performance. Now, relational algebra is being used on relational databases, right? That is, the data is stored in the form of tables. So, when the output is received, when we query the database and the output is received, it is also received in the form of tables or relations. So, in the form of input, we are giving what needs to be done and how are we expecting it to be done. Then, some operations are being performed on the database with the help of the query, right? And the output is in the form of tables or relations because data is stored in the form of tables or relations. All right? I hope this was clear. Now let's quickly discuss the relational algebra operations that we will be studying in the future. So relational algebra operations are divided into two categories. First are the basic or fundamental operations and the second one are additional or derived operations. We can understand from the name itself, these are the basic operations and these are derived from the basic or fundamental operations. The first one, basic operations, are select operation, that is denoted by sigma. Select, obviously, to select some data from the database. Then we have project, that is denoted with the pi. Projection is another operation that we need to perform in the database. Then we have union, that is denoted by the union sign. Then we have set difference, this is denoted by a hyphen, or you can say a minus sign. Then we have Cartesian product, denoted by the x or multiplication sign. And finally, we have the rename, which is denoted by rho. In the derived operations, we have set intersection, denoted by the intersection, assignment operation, denoted by the equal to. This is not equal to, actually, this is an assignment operator. That means we are assigning some value to some place that we'll discuss. Then we have the natural join, which is denoted by this. And in natural join, we are going to discuss three different types. Then we have the division operation, which is denoted by the division sign. And finally, we have the outer join, which also has three different types. All right. This was basically all for what is relational algebra and relational algebra operations. We are going to discuss all of these operations in the next video in detail with lots of examples. Don't forget to give this video a thumbs up if this helped you. Subscribe to the channel. Thank you so much for watching. If you have any doubts and queries, don't forget to mention them in the comment section below.